Welcome to our beginner-friendly series, Introduction to Python Programming. In this series, we'll embark on a journey into the world of Python, one of the most popular and versatile programming languages out there. Whether you're an absolute beginner or have some coding experience, this series will lay a solid foundation for your Python programming skills. Python is known for its simplicity, readability, and vast range of applications. From web development to data analysis, machine learning to automation, Python has it all. Whether you're interested in building websites, analyzing data, or creating powerful software, Python is the perfect language to get started with. Throughout this series, we'll cover the core concepts of Python programming. We'll start with the basics like variables, data types, and control flow. Then we'll dive into more advanced topics like functions, data structures, and file handling. By the end, you'll be equipped with the knowledge and skills to start building your own Python programs. To begin, we're going to be talking about variables and data types in programming. Now, before we dive into coding, let's understand what variables are and why they are important. In programming, variables are used to store and manipulate data. Think of variables as containers that hold different types of information, such as numbers, text, or Boolean values. They allow us to work with data dynamically and perform operations based on the stored values. Let's begin by exploring variable declaration. In most programming languages, variables are declared by specifying a name and assigning a value to them. In this code snippet, we declare four variables: age, temperature, name, and isStudent. We assign different values to each variable representing an age, temperature, name, and student status, respectively. The variable names can be chosen based on the context of your program. Now you can go ahead and type in this code, follow along on replit.com. Just create an account and open a new Python notebook, or continue with the desktop version. Now let's discuss different types of data types commonly used in programming. We'll start with integers and floats. Integers represent whole numbers without any fractional part, while floats represent numbers with decimal points. In our example, the age variable holds the value 25, and the temperature variable holds the value 98.6, representing a temperature measurement. It's important to choose the appropriate data type based on the nature of the data you're working with. In our case, age is an integer, and temperature is a float. Now, let's explore string and Boolean data types. Strings are used to represent text or characters. In this example, the name variable stores the string John Doe, which can be a person's name or any other text you want to manipulate in your program. Boolean variables only have two possible values, true or false. They are often used to represent logical conditions or states. In our example, the isStudent variable holds the value true, indicating that the person is indeed a student. Finally, let's explore more complex data types that allow us to store multiple values. Lists are ordered collections that can hold multiple values. In our example, the grades list contains four integer values representing grades. Tuples are similar to lists but are immutable, meaning their values cannot be changed once defined. The coordinate tuple represents a pair of coordinates, in this case, latitude and longitude. Dictionaries are key value pairs, allowing us to store and retrieve values based on a given key. The person dictionary contains information about a person, such as their name, age, and student status. Sets are unordered collections that contain unique values. In our example, the subject set represents a collection of subjects. And that concludes our tutorial on variables and data types in programming. We covered variable declaration, explored different data types, and provided code examples to help you understand each concept. With this knowledge, you can work with variables and different data types in any programming language. Now, we're going to talk about operators and expressions. Operators allow us to perform various operations on data, while expressions combine values and operators to produce new values. Now, before we dive into coding, let's understand what operators are and why they're important. In programming, operators are symbols that perform operations on one or more operands, values, or variables. They allow us to manipulate and perform computations on data in our programs. Python provides a wide range of operators, including arithmetic, assignment, comparison, logical, and more. Let's start by exploring some arithmetic operators, which allow us to perform mathematical calculations. In this code snippet, we declare two variables, x and y, and assign them to values. We then use arithmetic operators to perform various calculations. The plus operator performs addition. The minus operator performs subtraction. The asterisk operator performs multiplication. And the slash operator performs division. The percent operator calculates the remainder. The double asterisk raises x to the power of y. The double slash operator performs floor division, returning the quotient as an integer. Next, let's explore assignment operators, which allow us to assign values to variables. In this code snippet, we use an assignment operator to update the value of the variable x. The plus equals operator adds the value of y to x and assigns the result x. It assigns the result to x. So x would equal x plus y. The minus equals operator subtracts the value from y from x and assigns the result to x. The times equals operator, or the asterisk equals operator, multiplies x by y and assigns the result to x. The slash equals operator divides x by y and assigns the result to x. The percent equal operator calculates the remainder of x divided by y and assigns the result to x. And so on. The double slash equals operator performs floor division and assigns the result to x. And the double asterisk operator raises x to the power of y and assigns the result to x. Now let's explore comparison operators, which allow us to compare values and determine their relationship. In this code snippet, we use comparison operators to compare the values of x and y. The greater than operator checks if x is greater than y. The less than operator checks if x is less than y. The double equals operator checks if x is equal to y. The exclamation point equal operator checks if x is not equal to y. The greater than equal operator checks if x is greater than or equal to y, and the less than or equal to operator checks if x is less than or equal to y. And finally, let's explore logical operators, which allow us to combine multiple conditions and perform logical operations. In this code snippet, we use logical operators to perform logical operations on Boolean values. The AND operator returns true if both x and y are true. The OR operator returns true if either x or y, or both, is true. And the NOT operator returns the inverse of x or y. And that concludes our tutorial on operators and expressions in Python. We covered arithmetic, assignment, comparison, and logical operators step by step, explaining the logic and code behind them. With this knowledge, you can now effectively perform calculations, comparisons, and logical operations in your Python programs. Now, we're going to talk about control flow in Python, focusing on conditional statements and loops. Control flow allows us to determine the execution path of our programs based on certain conditions and perform repetitive tasks using loops. Now, before we dive into coding, let's understand the importance of control flow in programming. Control flow structures such as conditional statements and loops enable us to make decisions and repeat actions based on specific conditions. They give us the flexibility to control the flow of our programs and make them more dynamic. Let's start with if statements, which allow us to execute a block of code conditionally. In this code snippet, we declare a variable x and assign it to a value. We then use an if statement to check if x is greater than 5. If the condition is true, the indented block of code after the if statement is executed. In this case, x is greater than 5 is printed. Now, let's explore elif statements, which allow us to check additional conditions after an if statement. In this code snippet, we extend the previous example by adding an elif statement. The elif statement allows us to check another condition if the preceding if statement condition is false. If the condition after the elif statement is true, the corresponding block is executed. In our example, x is equal to 5, the message x is equal to 5 is printed. If none of the conditions are true, the else block is executed, and the message x is less than 5 is printed. Next, let's explore loops, which loops allow us to iterate over a sequence of elements. In this code snippet, we have a list of fruits. We use a for loop to iterate over each fruit in the list. The variable fruit takes on the value of each element in the list during each iteration. The indented block of code within the for loop is executed for each iteration, printing each fruit. And lastly, let's explore while loops, which allow us to repeatedly execute a block of code while a condition is true. In this code snippet, we initialize a variable count to 0. We then use a while loop to repeatedly execute the indented block of code as long as the condition count is less than 5 is true. Inside the loop, we print the current value of count and increment it by 1 in each iteration. And that concludes our tutorial on control flow in Python. We covered conditional statements, including if and elif statements, as well as for and while loops. With this knowledge, you can effectively control the flow of your Python programs, make decisions based on conditions, and perform repetitive tasks. Now, we're going to talk about functions. Functions are an essential concept in programming, allowing us to encapsulate reusable blocks of code. Now, before we dive into coding, let's understand the importance of functions in programming. Functions allow us to break our code into modular pieces, making it more organized, reusable, and easier to maintain. They help us avoid code duplication and promote code reusability. Let's start by learning how to define a function in Python. In this code snippet, we define a function called greet using the def keyword. The function name greet can be chosen based on the context of your program. Essentially, you change this right here. Inside the function, we have a single line of code that prints the greeting message. Now that we have defined our function, let's learn how to call it. In this code snippet, we call the greet function by simply writing its name followed by parentheses. When the function is called, the code inside the function's block is executed, and the greeting message is printed. Functions can also accept arguments, allowing us to pass values into the function for processing. In this code snippet, we redefine the greet function to accept an argument, name, inside the parentheses here. Inside this function, we include the name parameter in the greeting message. When calling the function, we pass the value John as an argument. So here we run greet with the parameter John. The function then uses this value to personalize the greeting message. So when we enter John, the function uses name to say, "Hello, John, welcome to our channel." Functions can also return values, which can be useful for further processing or storing results. In this code snippet, we define a function called square that takes an argument x and returns the square of x. The return statement is used to specify the value to be returned from the function. When calling the function and assigning the return value to the variable result, we can then print the result to the console. And that concludes our tutorial on functions in Python. We covered function definition, function calling, passing arguments, and returning values. With this knowledge, you can effectively use functions to modularize your code, improve code organization, and promote code reusability. Now, we're going to talk about fundamental data structures in Python: lists, tuples, and sets. Data structures are crucial for organizing and manipulating data in any programming language. Now, before we dive into coding, let's understand the importance of data structures in programming. Data structures allow us to store, organize, and manipulate collections of values. They provide different ways to represent and access data, depending on our specific needs. In this video, we'll focus on 3 essential data structures in Python: lists, tuples, and sets. Let's start with lists, which are versatile and widely used in Python. In this code snippet, we create a list called fruits using square brackets. Lists can contain multiple elements of different data types. In our example, we have a list of fruits. We can access and manipulate elements in a list using indexing. Indexing starts from 0, so fruits 0 will retrieve the first element, which is apple. We can append new elements to the list using the append method, as demonstrated with orange. We can also modify an element by assigning a new value to a specific index, as shown with kiwi. Next, let's explore tuples, which are similar to lists but are immutable. In this code snippet, we create a tuple called coordinates using the parentheses. Tuples can store multiple elements just like lists. However, tuples are immutable, meaning their values cannot be changed once defined. In our example, coordinates represents latitude and longitude values. Tuple unpacking allows us to assign the values of a tuple to separate variables. In this case, we unpack the coordinates tuple into lat and lon variables. We can then access and use these values individually. Finally, let's explore sets, which are unordered collections of unique elements. In this code snippet, we create a set called subjects using curly braces. Sets can only contain multiple elements, but each element is unique. Duplicate values are automatically removed. In our example, subjects represents a collection of school subjects. We can perform various operations on sets. The in operator checks if an element is present in the set, as demonstrated with math. We can add elements to a set using the add method, as shown with history. Elements can be removed using the remove method, as demonstrated with English. And that concludes our tutorial on Python data structures, lists, tuples, and sets. We covered the basics of each data structure, including creation, access, manipulation, and operation. With this knowledge, you can effectively work with these data structures and organize your data in Python. Now, we're going to talk about dictionaries in Python. Dictionaries are powerful data structures that allow us to store and retrieve data using key-value pairs. Now, before we dive into coding, let's understand what dictionaries are and why they're important. Dictionaries are unordered collections of data that store values in key-value pairs. Each value is associated with a unique key, allowing us to efficiently retrieve and manipulate data in Python. Dictionaries are widely used for tasks such as storing user information, mapping values, and organizing data. Let's start by learning how to create dictionaries in Python. In this code snippet, we create a dictionary called student using curly braces. The dictionary contains key-value pairs, where each key is a string, and each value can be of any data type. In our example, student stores information about a student. Now that we have created our dictionary, let's learn how to access its elements. In this code snippet, we access the elements of the student dictionary. We can use square brackets and provide the key to retrieve the corresponding value. Alternatively, we can use the get method, which returns the value associated with the given key. In our example, we print the name and age of the student. Dictionaries are mutable, which means that we can modify their elements. In this code snippet, we modify the elements of the student dictionary. We assign a new value to the age key, update the major key, and add a new key value pair for the university. Dictionaries offer a flexible way to update and expand our data. Dictionaries provide several useful operations for manipulating and working with data. In this code snippet, we perform common dictionary operations. The len function returns the number of key value pairs in the dictionary. The keys method returns a list of all the keys in the dictionary. The values method returns a list of all values. The items method returns a list of key value pairs as tuples. These operations allow us to explore and extract information from dictionaries efficiently. And that concludes our tutorial on dictionaries in Python. We covered dictionary creation, accessing elements, manipulating data, and performing common operations. With this knowledge, you can effectively work in dictionaries and store key value pairs in Python. Now we're going to talk about exception handling in Python, which is a critical skill for writing robust and error-tolerant code. Exception handling allows us to gracefully handle errors and prevent our programs from crashing. Now before we dive into coding, let's understand why exception handling is important. In Python, when an error occurs during program execution, it raises an exception. Without proper exception handling, these exceptions can cause our program to terminate abruptly. Exception handling provides a way to anticipate and handle these errors, allowing our programs to continue executing gracefully even in the presence of errors. Let's start by learning how to handle exceptions using the try except block. In this code segment, we use the try except block to handle exceptions. Inside the try block, we write the code that might raise an exception. In this case, we attempt to divide 10 by 0, which raises a 0 division error. In the except block, we define the code to handle the exception. Here, we simply just print out an error message. By using exception handling, our program continues to execute even though an error occurs. We can also handle specific exceptions and execute different code based on the type of exception. In this code snippet, we handle the zero division error specifically and provide a custom error message. We use the except keyword followed by the exception type. We can also use the as keyword to assign the exception object to a variable, or e in this case. This allows us to access additional information about the exception, such as the error message. The else clause allows us to execute code if no exceptions occur. In this code snippet, we use the else clause to print a success message if no exceptions occur. If a zero division error occurs, the except block is executed instead. The else clause is useful when we want to separate the exception handling logic from the code that should execute if no exceptions occur. And the finally clause allows us to execute code regardless of whether an exception occurred or not. Let's run this first. In this code snippet, we use the finally clause to print in a completion message. The code inside the finally block is executed regardless of whether an exception occurred or not. It ensures that certain actions, such as closing files or releasing resources, are performed even if an exception is raised. And that concludes our tutorial on exception handling in Python. We covered the basics of handling errors gracefully using try-except blocks, handling specific exceptions, and using else and finally clauses. With this knowledge, you can write robust and error-tolerant code that gracefully handles exceptions. Now we're going to talk about the fundamentals of object-oriented programming, or OOP, in Python. OOP is a powerful paradigm that allows us to structure our code and objects around their interactions. Now before we get into coding, let's understand the importance of object-oriented programming in Python. Object-oriented programming enables us to create modular, reusable, and organized code. It allows us to model real-world entities as objects, which have attributes or data, and behaviors as methods. By encapsulating data and methods together, we can build more maintainable and scalable programs. Let's start by learning how to write a class, which serves as a blueprint for creating objects. In this code snippet, we define a class called car using the class keyword. A class acts as a template that defines the properties and behaviors of objects. In our example, we create a basic class with no attributes or methods. Once we have a class, we can create objects, also known as instances of the class. In this code snippet, we create two objects, car1 and car2, by invoking the class as if it were a function. Each object is independent and has its own set of attributes and behaviors. We can create as many objects as we need from a single class. Now, let's enhance our class by adding attributes and methods. In this code snippet, we define the car class with a constructor method in it. Right here. The constructor is invoked automatically when we create an object. It initializes the object's attributes, make, model, and year using the provided values. We also define two additional methods, startEngine and drive, which represent the behaviors of the car objects. We create two car objects, car1 and car2, and invoke their methods. One of the key features of OOP is inheritance. Inheritance allows us to create new classes based on existing ones. In this code snippet, we create a new class called electric car that inherits from the car class. The electric car class inherits all the attributes and methods from its parent class. We can also add new attributes and methods specific to electric cars, such as the charge method. We create an electric car object and demonstrate how it inherits and extends the behaviors of the car class. And that concludes our tutorial on object-oriented programming in Python. we covered the basics of creating classes, creating objects, adding attributes and methods, and using inheritance. With this knowledge, you can apply object-oriented programming principles to structure and organize your code effectively. Now, we're going to explore the fundamentals of classes and objects in Python. Classes are the building blocks of object-oriented programming, allowing us to define our own custom data types and their associated behaviors. Before we dive into the coding, let's understand the concept of classes and objects. In Python, a class is a blueprint or template for creating objects. It defines the attributes or data and the methods, functions that the object of the class will have. Objects, also known as instances, are individual entities created from a class. They have their own unique set of attributes and can perform actions defined by the class methods. Alright, so let's start by having a class template here. In this code snippet, we define the circle class with 3 methods. The init method is a special method called the constructor, which is invoked automatically when an object is created. It initializes the object's attribute radius using the provided value. We also define 2 additional methods, getArea and getCircumference, which calculate and return the area and circumference of the circle. Once we have a class, we can create objects or instances of the class and access their attributes. In this code snippet, we create 2 circle objects, circle1 and circle2. By invoking the circle class with radius values is how we created the 2 objects. We can access the object attributes using the dot notation. Here, we print the radii of both circles. We also invoke the methods of the objects getArea and getCircumference to calculate and store the area and circumference values, which we then print. And that concludes our tutorial on classes and objects in Python. We covered the basics of creating classes, defining attributes and methods, creating objects, accessing objects, attributes, and methods. And now, with this knowledge, you can start creating your own custom classes and objects in Python, organizing your code in a more structured and reusable manner. Now, we're going to talk about the concepts of modules and packages in Python. Modules and packages allow us to organize our code into reusable components, making our programs more modular and maintainable. Before we dive into coding, let's understand the importance of code organization and reusability. As our programs grow in complexity, it becomes essential to organize our code into logical units that can be reused across different parts of our application. Modules and packages provide a way to achieve this by grouping related code together and allowing us to import it and use it wherever needed. Let's start by learning how to create a module, which is a Python file containing code that we can import and use in other scripts. First thing we're going to have to do is open this here and create a new file. In this code snippet, we create a module called mathoperations.py. It contains 2 functions, add and subtract. These functions perform basic mathematical operations. We save this code in a separate Python file with the .py extension. Once we have a module, we can import it into other Python scripts and use its functions. In this code snippet, we import the math operations module using the import keyword. We can then access these functions defined in the module using the dot notation. Here, we call the add and subtract functions and print the results. To organize our code even further, we can create packages, which are dictionaries that contain multiple modules. Now, Replit is, okay, there we go. So let's go ahead and create that directory now. Let's create a folder called my package. Move math into my package. In this directory structure, we have a package named myPackage, which contains multiple modules, mathoperations.py and geometry.py. The init.py file is necessary to indicate that the directory is a package. Now, in our main.py, we import the math operations module from the myPackage package using from import statement. We can then access the functions defined in the module as before. And that concludes our tutorial on modules and packages in Python. We covered the basics of creating modules, importing them into other scripts, and creating and using packages to organize related modules. From this knowledge, you can organize your code effectively, promote reusability, and build more maintainable Python programs. Now we're going to explore Python's standard library, which is just a bunch of modules that come bundled with Python. These modules provide ready-to-use functionality for a wide range of tasks, saving us time and effort. Now before we dive into coding, let's understand the importance of libraries and the Python standard library. Libraries are collections of pre-existing code that provide solutions to common problems. The Python standard library, included with every Python installation, offers a vast array of modules that cover areas like files, operation, data manipulation, networking, and more. By utilizing these modules, we can save time and avoid reinventing the wheel. Let's start by learning how to import and use a module from the Python standard library. In this code snippet, we import the random module from the Python standard library using the import keyword. The random module provides functions for generating random numbers. Here, we use the randint function to generate a random integer between 1 and 10, and then we print it. Once we import a module, we can use its functions, classes, and constants to perform various tasks. First, while that's loading, in this code snippet, we import the datetime module from the Python standard library. The datetime module provides classes for working with dates and times. Here, we use the now function from the datetime class to get the current time and date, and then we print it. So while we were running, it looks like it already picked this up and printed the date and time here. The Python standard library also contains numerous modules for different purposes. Let's explore a few more examples. Alright, so in this code snippet, we import the math, OS, and CSV files from the Python standard library. The math module provides mathematical functions, the OS module allows us to interact with our operating system, and the CSV module enables us to read and write CSV files. Here, we demonstrate the usage of functions from each module, such as calculating the square root, getting the working directory, and reading a CSV file. And that's going to conclude our tutorial on the Python standard library. We explored how to import and use modules from the library, allowing us to leverage existing code for various tasks. The Python standard library provides a wealth of functionality that can enhance our Python programs and save us time and effort.